Welcome to IB Chemistry exam preparation, exam tips for both standard level and higher level. Today I'm going to cover topic 8, acids and bases. We will answer some practice questions on paper 2 for standard level. So let's get started. Starting with question number 1. Iron 2 sulfide reacts with hydrochloric acid in order to form hydrogen sulfide. Draw the Lewis electron dot structure of hydrogen sulfide. Through our lesson for today and while answering the questions related to acids bases, we're going to find that the questions are integrated with all other chapters. So there will be more than one idea presented inside the question. Some of them is taken from the acid bases chapter and others are taken from the previous chapters. As in question number 1I, it's asking to calculate or to find out, the Lewis and to draw the Lewis electron dot structure of the hydrogen sulfide. So the sulfur is my central atom. I have 6 valence electrons presented inside my sulfur. Then there will be 2 hydrogens which will be attached by a single covalent bond. So this is for AI. Predict the shape of the hydrogen sulfide molecule. This is the molecular shape which is the actual. It is definitely the V shape, or we can name it as the bent shape. Here the electron domain around the sulfur it's 4, so the electron domain geometry is a tetrahedral shape, but due to having the lone pairs, so there will be a repulsion, then the molecule will have the V shape or the bent. In aqueous solution, hydrogen sulfide acts as an acid. State the formula of the conjugate base. We need to remember that if the question is asking me to find the base, so I need to remove a hydrogen ion. So if we remove a hydrogen ion, our final answer will be HS negative. Continuing with double I, saturated aqueous hydrogen sulfide has a concentration of 0.1. So this is the concentration of the hydrogen sulfide and the pH is 4. Determine whether it's a strong or a weak acid. In order to know whether it's a strong or a weak, we need to compare the pH given to the hydrogen ion concentration, which is also given inside the question as being 0.1. So if we compare, in order to have a strong acid and it dissociate completely inside the water, the pH should be equal in this situation for a 1, since the pH is minus the logarithm of the 0.1, which is equal to 1. If we compare both pHs, we're going to find that they are not the same. So this is an indication that the acid, which is the hydrogen sulfide, is actually a weak acid. So what can we write? The answer is definitely it's a weak acid. And in order to explain, we're going to say if the H2S is a strong acid, its pH should equal to 1, since its H positive ion concentration equal 0.1 mole over decimeter cube. So this is the answer. Continuing with the triple, calculate the hydroxide ion concentration in saturated aqueous hydrogen sulfide. So if we go to the question, we're going to have the pH, which is 4. The question is asking me to find out the hydroxide ion. So I'm going to find firstly the POH, which is equal to 14 minus 4, and definitely it's a 10. Finally, in order to find the concentration of the OH negative, it will be a 10 to the power of negative 10. So your final answer is 1 times 10 to the power of negative 10, and you are done. Here you need to remember that the pOH is equal to logarithm the concentration of OH negative. So if the pOH equals 10, how can we find the OH negative? So we need to overcome the logarithm. So this would be 10 to the power of negative the pOH. So I can give here a simple rule. Anytime you want to determine the OH negative concentration, it will be 10 to the power of negative the pOH that you have. Continuing now with question number 2. Write the equation for the reaction of calcium hydroxide and hydrochloric acid. So this is an acid-base chemical reaction actually. So I'm going to add the calcium and the chlorine will react together in order to form the salt. So this produces calcium chloride plus the hydrogen and OH. They will both react in order to form the water. So this is CaCl2, and there will be the water molecule as well produced. Then we're going to balance the chemical equation by multiplying 2 beside the hydrochloric acid to balance the Cl, and another 2 here to balance the hydrogen. I. Determine the volume in decimeter cube of 0.15 calcium hydroxide solution. So in this question, it's asking me to find out the volume. So I'm going to underline my equation. So here I need to calculate the volume in decimeter cube, and I have its concentration, which is 0.015. Needed to neutralize, I have the volume of the hydrochloric acid, so this is 35.0, and I have the concentration, which is 0.025. So in order to answer this question, we need to refer to stoichiometry chapter. So firstly, I'm going to find out the mole of the hydrochloric acid, then to apply on a mole ratio. The mole, it will be the concentration times the volume. The concentration is 0.025 multiplied by the volume. It should be divided over 1,000 since I need to use decimeter cube. And actually my final answer is 8.8 times 10 to the power of negative 4. Now I'm going to continue with my mole ratio. So if I want to find out the mole of the calcium hydroxide, it is half the mole number of the hydrochloric acid. So it is 8.8 times 10 to the power of negative 4 divided over 2. Here I'm referring to the mole ratio, of course. So this would be 4.4 times 10 to the power of negative 4. And finally, I need now to calculate the volume. So if I'm going back into the rule, I'm going to find that the volume, it will be my mole number over the concentration. The mole, it is 4.4 times 10 to the power of negative 4 divided over the concentration, which is 0.025. And our final answer, it will be 0.029 decimeter cube. For the final answer, you're going to find that I have two significant figures, and this is related to what is given inside the question. Here I have two significant figures. Here I have three significant figures. Here I have two. So my final answer should be with a two significant figures number. Continuing now with question triple. Saturated calcium hydroxide solution is used to test for carbon dioxide. Calculate the pH of the calcium hydroxide as a strong base. So I have a base. I need to calculate the pH. What is given is the OH negative. So I'm going to calculate firstly the pOH. But there is here one very important thing to remember. The calcium hydroxide, it is CaOH by 2. So if I want to calculate the OH negative concentration, since I have two hydroxide ions presented inside the formula, so the hydroxide ion concentration, it will be 2 times 2.33 times 10 to the power of negative 2. So it is 0.0466. I need to remember that the concentration, it will be affected according to the formula. Now I will continue my pOH value, which is minus log for the 0.0466, and it is 1.332. Finally, I'm going to calculate the pH, which is 14 minus 1.332, and my final answer is 12.668. If you look at my final answer, you're going to find that it is out of 3 decimal places. I'm talking about pH. So it's 3 significant figures number actually. And if I'm going to my question, this is 3 significant figures. So my final answer should be 3 significant figures. Here, remember that in case of the pH, the decimal places are the significant figure number. Equals the significant figures. This is so important to remember for your final answer. Continuing with question number 3. Phosphoric acid can undergo stepwise neutralization forming amphiprotic species. Formulate an equation for the reaction of 1 mole of phosphoric acid with another 1 mole of sodium hydroxide. Why it's important to consider how many mole number? This is for the balancing part. So if I want to start writing my equation, I have H3PO4 plus sodium hydroxide. The point here, this is a triprotic acid. So there are 3 different hydrogen ions presented. Since the question is telling me only 1 mole, so when you want to go through the proton donor as a definition for Bronsted-Lowry, you're going only to remove 1 hydrogen, so not to disturb the balancing at the end and to have 1 mole. So for the cross multiply, you're going to cross multiply between the Na and between the H2PO4 as a negative. So you're going only to remove 1 hydrogen. This is 1 and this is 1. So your final answer should be NaH2PO4 plus H2O. You're not going to cross multiply with the phosphate as an ion. So it's not between the Na and the PO4 complete. So it's not this one. Since in the question it's asking me to write down an equation using only 1 mole of phosphoric acid. So in this situation, I'm going to have 1 mole to 1 mole at the end, and the chemical balance equation, it will be already completed and balanced without adding any other number. Formulate 2 equations to show the amphiprotic nature of H2PO4 negative. When I'm going to go through the amphiprotic, remember that it's the behave as an acid and the base nature. So it could be a proton donor or proton acceptor. So I will start with acting as an acid. What I'm going to do, I'm going actually to take my amphiprotic species and I'm going to add it into water. So H2PO4 negative plus H2O. Here I need to remember that it is a weak, so it would be equilibrium. Since it acts as an acid, so it's a proton donor, so it will donate a hydrogen, so this will form HPO4. It will become more in negative as -2 plus the H3O plus. Now continuing with the second situation, if it acts as a base. So now I have acting as a base. So as a base, I'm going to take the ion another time, H2PO4 negative plus H2O. It's also equilibrium, but it will be a proton acceptor this time. So it will be H3PO4, so it will accept H positive and it will become a neutral plus OH negative. It's a 1 mark for each of the first equation and the second equation as well. Continuing with C, calculate the concentration of H3PO4 if 25 cubic centimeter is completely neutralized. This is a very important word. Completely neutralized, it's a clue for writing the chemical balance equation. If it's telling you that it's completely neutralized, so actually all these hydrogen ions, they are totally been neutralized. So you will cross multiply between the sodium and the phosphate ion actually. So let's start with our equation. H3PO4 plus NaOH to form the salt and water. Since completely neutralized, you will cross between the Na and the PO4. This is 1, this is 3. So your salt is Na3PO4 plus your water molecule. Now you're going to balance. So you're going to multiply here by 3. And going through the water molecule, I have 3 hydrogens and 3 hydrogens, it's a 6. So you're going to multiply here by another 3. Now going back to the question, what do we have? Calculate the concentration of H3PO4. So I need the concentration. And you have the volume, which is a 25. Is completely neutralized by the addition of a 28.4. So the volume here is 28.40. And your concentration is 0.5000. Now the first step is definitely to find the mole, then to continue with the mole ratio. I will start with the mole of NaOH, which is the concentration multiplied by the volume, which is 0.5 multiplied by 28.4 divided over the 1000. And it is 0.0142. If we want to check our answer, so to make sure having the number of significant figures, here we need to consider having at the end 4 significant figures. So looking at the final answer, I'm going to add a 0 right here, so to have the correct number of significant figures. Now, according to the mole ratio, we're going to have the mole of H3PO4. Going to the balanced chemical equation, it is divided over 3. So it is 0.01420 divided over 3. And our final answer is 4.733 times 10 to the power of negative 3 mole number. Now the last step is to find out the concentration, which is mole divided over the volume. So we're going now to substitute. I will take my mole number, which is 4.733 times 10 to the power of negative 3, and I'm going to divide it over the volume, and you need to remember that the volume should be divided over 1000, so it is divided over 0.0250. And looking at your final answer should be correct into 4 significant figures, so it will be 0.1893 mole decimeter to the power of negative 3. Looking at the significant figures number, here you have 4, here you have 4, and here you have 4. So your final answer should be at the end by 4. Outline the reason that sodium hydroxide is considered a Bronsted-Lowry base. So here, as if you want to write down the definition, what is a Bronsted-Lowry base? It is when the NaOH is dissociated in water, it can form hydroxide ions. These hydroxide ions which are presented, they can act as a proton acceptor. The ions which are the hydroxide can accept proton. So proton acceptor. So for the Bronsted-Lowry base, here we need to remember that they have the ability to be a proton acceptor, and the sodium hydroxide, when we consider the OH negative itself, it's presented when the NaOH is presented inside water. So the OH negative, it can behave as a proton acceptor. And when it accepts the hydrogen ion, it will form the water molecule. Continuing with question number 3, a molecule of citric acid is shown. The equation of the first dissociation of citric acid in acid is given. Identify a conjugate acid-base pair in the equation. So if you look at the equation and you compare before and after, you're going to find that the acid right here, it behaves as a proton donor. So this is the conjugate base, and of course this is the base, and this is the conjugate acid. So I have actually 2 pairs. I can take the C6H8O7 and I have the C6H7O7 negative. I have another possible answer, which is the water and the H3O plus. You can choose one of them, of course. The value of the equilibrium constant for the first dissociation is 298, which is 5 at 298 is 5.01 times 10 to the power of negative 4. Look at this Kc value, which is very small compared to 1. So here we can refer to the equilibrium chapter, into which the reactants are more favored. State, giving a reason, the strength of the citric acid. If I want to go through the strength, it is definitely a weak acid. But the question is telling me to state. How can I know that it's a weak? I have more than one way. Firstly, if you look at the chemical balance equation, it's equilibrium. So it do not fully dissociate in water. This is one of the possible answers. The second thing is if I look at my Kc value. So if you look at your Kc value, you're going to find that it's smaller than 1. So as if the equilibrium lies to the left and the reactants are more favored. So you will write down that it's a weak acid, and you can say for the reason the acid partially dissociate in water, and of course this is due to the equilibrium presented. Or you can have another answer. You can say it's a weak acid, and for the reason you will write, and this is for the reason the K is smaller than 1. So the equilibrium lies to the left. So you have two possible ways for your reasoning. Continuing with the triple, the dissociation of citric acid is an endothermic process. State the effect on the hydrogen ion concentration and on the equilibrium constant of increasing the temperature, and on the equilibrium constant if the temperature it was increased. So if I'm going to go back, this is my balanced chemical equation. According to the equation, they are telling me that this is actually an endothermic chemical reaction. So energy it's now apart from the reactants. So if the temperature increases according to the equilibrium, in which direction the chemical equilibrium will shift? It will shift to the right. So the question is telling me what's the effect on the hydrogen ion. This is my hydrogen ion. It will definitely increase. So the concentration of H positive, it will increase, which is related to the hydronium ion. And the second part, it's asking me also about the Kc. So it will also increase. So let's go to the question. So what is the effect on the H positive concentration? I'm going to say that increases due to the lifting part, and effect also on equilibrium constant, it also increases. Here we need to remember that the only factor that affects the equilibrium constant, which is the Kc value, is definitely the temperature factor. So 1 mark for each. Outline 1. Laboratory method of distinguishing between solutions of citric acid and hydrochloric acid of equal concentration. Stated the expected observation. We have several experimental methods that can be used to distinguish between the weak and the strong. So we can say, for example, testing the electrical conductivity and the question is also asking me to write down the expected observations, and it is between the citric acid and between the hydrochloric acid. So definitely the hydrochloric acid will have higher conductivity since it's a strong acid. Continuing with question number 4. For question B, you can also focus on testing the pH. You can also focus on the addition of a metal and the rate of the chemical reaction. You can go through also the addition of sodium carbonate, and you can base also on the rate as well. For 4, both vinegar, a dilute aqueous solution of ethanoic acid, and bleach are used as a cleaning agents. Outline why ethanoic acid is classified as a weak acid. You need to say that this acid partially dissociates in water, forming H positive ions. Now we have the B. A solution of a bleach can be made by reacting chlorine gas with sodium hydroxide, Cl2 plus sodium hydroxide to produce NO hypochlorite or chlorate plus sodium chloride and water. Suggest with reference to Le Chatelier principle why it's dangerous to mix vinegar and bleach together as cleaners. So number 1, vinegar can react with NaOH. This will cause to decrease the concentration of NaOH. Now we need to refer to the shifting. The equilibrium will shift to the left, and this will cause to form chlorine, which is toxic gas, causing to form Cl2 gas, which is toxic. Now we have question number 5. Carbonated water is produced when carbon dioxide is dissolved in water under pressure. The following equilibria are established. Equilibrium 1, you have carbon dioxide gas turns into carbon dioxide aqueous. Equilibrium 2, carbon aqueous plus water to form hydrogen ion and the hydrogen carbonate. Carbon dioxide acts as a weak acid. Distinguish between a weak and a strong. Definitely you're going to write that a weak partially dissociates in water, forming H positive ions, but in case of strong it is completely dissociates or ionizes. It's the same in water, forming the hydrogen ions. The hydrogen carbonate ion produced in equilibrium 2 can also act as an acid. State the formula of the conjugate base. So it's asking about the hydrogen carbonate ion, which is HCO3 negative, and it is presented inside equilibrium number 2. We want to find out the conjugate base, so we need to remove H positive. So if we want to remove the H positive, our final answer will be CO3 and it will become more negative. When a bottle of carbonated water is opened, these equilibria are disrupted. State giving a reason how a decrease in pressure affects the position of equilibrium 1. So I want to go through the decrease in the pressure. I will go back to equilibrium number 1. So I have here 1 mole of gas. Here I have 0 mole of gas. So if the pressure decrease, it will go to the direction in which we have more mole number. So it will shift actually to the left in this situation. So we need now to go through the answer. So state giving a reason how a decrease affects the position. We're going to say when the pressure decreases, equilibrium shifts to the left in the direction of having more mole of gas, as we have 1 mole reactants or reactant and 0 mole of gaseous products. B. Soda water has sodium hydrogen carbonate dissolved in carbonated water. Predict referring to equilibrium 2 how the added sodium hydrogen carbonate affect the pH. Assume pressure and temperature remain constant. So predict how addition of sodium hydrogen carbonate. So we're going to add NaHCO3 and we're going to see how this will affect the pH. So let's go back to the balanced chemical equilibrium, which is equilibrium number 2. So I want to add NaHCO3. You're going to find that the common ion is HCO3. So the concentration of HCO3 negative will increase. We are referring to this balanced chemical equation, which is equilibrium number 2. So what will happen? If you add NaHCO3, the concentration of HCO3 negative increases, so the equilibrium will shift to the left. So when it shifts to the left, what will happen to the hydrogen ion concentration? The hydrogen ion concentration will decrease due to shifting. So what will happen to the pH? The pH, it will increase. So this is how we need to think about the question. We look at the shifting part, then we consider what happens to the hydrogen ion concentration, then we refer to the pH. So let's go back to the question. So predict referring to equilibria 2 how added sodium hydrogen affects the pH. We're going to say, as first point, the concentration of HCO3 negative will increase. As products. So what will happen to the equilibrium? The equilibrium, to offset this problem, will shift to the left. So continuing with the second part of our answer, the H positive ions concentration will decrease and therefore the pH increases, so it becomes less acidic. 100 cubic centimeter of soda water contains 3 times 10 to the power of negative 2 gram of sodium hydrogen carbonate. Calculate the concentration in mole per decimeter cube. So this is only unit converting. So I need to calculate the mole number. Mole equal mass divided over the molar mass. I have 3 times 10 to the power of negative 2 divided over the molar mass. For the sodium hydrogen carbonate, you have 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. So it is 84.01 using the periodic table. And our final answer as mole number, it is 0.00357. If we want to take into consideration the number of significant figures number here, so it's a 2 significant figure for the mass, and you have another 4 significant figures for the molar mass. So your final answer should be actually a 2. So I'm going to write it as a 2, which is 3.6 times 10 to the power of -4 mole number. I already rewrite it as a scientific notation way. Now continuing with the concentration. So the concentration, it will be my mole number divided over the volume. So it's 3.6 times 10 to the power of -4 divided over the volume. Here is in cubic centimeter, so I need to convert into decimeter. So it is divided over 1000. So it is 0.100, and our final answer is 3.6 times 10 to the power of -3 mole over decimeter cube. And we are done. Identify the type of bonding in sodium hydrogen carbonate. Firstly, it's asking me between the sodium and between the hydrogen carbonate. This is integrated with chapter number 4, talking about ionic, covalent, and metallic. So it is between the Na positive and between the HCO3 negative. The type of bond between both, it is definitely an ionic bond. Between hydrogen and oxygen in the hydrogen carbonate, so I'm talking about the bond which is right here inside my ion. So it's non-metals together, it is considered as a covalent bond. And this actually was our last question for our practice for today. So thank you for watching.